In this tutorial, we're going to be looking at how you can use the SOHCAHTOA method to get the basic trigonometric ratios, which are the sine, the cosine, and the tangent. We're going to be looking at how the method was derived, the SOHCAHTOA method, and how it can be used. So let's get started. How do you use the SOHCAHTOA method to get the basic trigonometric ratios, which are the sine, the cosine, and the tangent? Let's start by looking at a right angle triangle. So if you have a right angle triangle such as this side is labeled P, labeled Q, and labeled R. And these are P, this small letter P, this R, and this is Q. And our theta is being defined at angle P. To show that this is a right angle triangle, we have a sign here. Now, let's go back to the beginning where we talk about the Pythagoras theorem. According to Pythagoras, the longest side of a right angle triangle is named the hypotenuse. Let me clear that and rewrite it to be more clear. The hypotenuse. So the side in which the angle is facing, just like this angle is facing this side, this is called the opposite. And the third side is the adjacent. So we have the hypotenuse, the opposite, and the adjacent. So now, as what we are looking at today, the SOHCAHTOA. The SOHCAHTOA method is gotten from the Pythagoras theorem, the Pythagoras way of naming angles. So if you want to define our sine of angle, so this is going to be equal to the opposite over hypotenuse. The opposite over hypotenuse. If you want to define our cos, that's the cosine of angle. This is going to be equal to the adjacent of hypotenuse. And the tangent of angle will be equal to the opposite of adjacent. So let's now bring in this into the triangle that we have here. So according to this triangle, we have the sine to be the opposite of hypotenuse. And according to this triangle, the opposite is P, which is QR, over this is the opposite QR, and hypotenuse is PQ. And this equals to P over R. You see how simple that is? You can easily get our sine, which is just opposite of hypotenuse. Whatever the angle is facing is the opposite, and the longest side is the hypotenuse. To get the cosine, that's the adjacent over hypotenuse. And according to this right angle triangle, the adjacent is PR over hypotenuse, which is PQ. And that is Q over R. And the tangent is opposite over adjacent. The opposite according to this triangle is QR over the adjacent is PR. And this equals to P over Q. So we now have our sine and cosine and tan. Now, going back to SOHCAHTOA. SOHCAHTOA is just a way of simplifying this. We have this, the sine is the SO, cos is the CA, and tan is the TOA. So watch out. We have our sine to be SO, and this is SOH. This is sine. The O is opposite, and the H is adjacent. Oh, hypotenuse, sorry. So we define the sine by opposite over hypotenuse, which is sine. So do you see where the SO is coming from? SOH. The same thing with cos. The A is adjacent. The A is adjacent. And the H still remains the hypotenuse. So the cos is adjacent over hypotenuse. Just like what we have here. And the tan is the TOA, which is opposite over adjacent. Opposite over adjacent. You now have tan to be opposite over adjacent. So if you simply note your SOHCAHTOA, so you note that if you're looking for sine, that's simply opposite over hypotenuse. If you're looking for cos, that's adjacent over hypotenuse. And if you're looking for tan, that is opposite over adjacent. To illustrate this further, let's look at an example. If you are given a triangle such as this, we have a right angle triangle. This is labeled A, B, C. And this is a right angle triangle, and we have our theta here. So according to this triangle, this is 4, this is 3, and this is 5. So we have to find the sine, the cosine, and the tangent. So our sine is the SO, which equals to opposite over hypotenuse. So according to this triangle, where is the opposite? We have our opposite here, and we have our hypotenuse here. So the sine of theta equals to 4 over 5. You see how simple that is? The cos of theta, that is the CAH. And as you can guess right, this is adjacent of hypotenuse. So the adjacent here is 3 and the hypotenuse is 5. Once again, we have noted that the longest side is the hypotenuse. The side facing the angle, just as this, is the opposite, and the last side is the adjacent. So to look for the tan theta is the TOA. So O is adjacent and O is opposite and A is adjacent. So tan theta equals to opposite over adjacent. So where is the opposite? 4 over adjacent, which is 3. So this is simply how you can use the SOHCAHTOA to find the sine, the cosine, and the tangent, which are the basic trigonometric ratios of angles. And that is simply how you can use the SOHCAHTOA method to get the sine, the cosine, and the tangent. So we have an exercise here. Try this. Find the sine, cosine, and the tangent of the angle alpha below. So we have a triangle where we have 1, 1, and the hypotenuse is √2. So feel free to post your answers in the comment section below, and we're going to get back to you as soon as possible. If you have any questions throughout the course of this tutorial, don't forget to post your questions in the comment section below. If you like this tutorial, don't forget to like and share.